A hexagon does not care whether you believe in it. It is the only shape that tiles a flat surface with the smallest amount of perimeter. That is the reason your beehive, your snowflake, and the carbon atoms in your blood all converge on the same six-sided form. A mathematician at the University of Michigan finished proving it in 1999. It is no longer mysticism. It is a theorem. Nobody taught you that. They did not teach you what the word sacred actually means in the phrase sacred geometry. And they did not teach you that there was once an entire discipline taken seriously by Plato, Euclid, and Kepler that studied these shapes as the operating language of reality. It had a name. It was removed on immutable mechanics. We are going to give you the piece that was kept out. And the place to begin is exactly where the ancients did. With one question: what does the word sacred actually mean? Open any Greek dictionary. Look up the word geometry. It does not say what you think it says. It says, in plain Greek, the measurement of the earth. The Greek roots are geo, which means earth, and metron, which means measure. Put them together. Geometry is earth measurement. According to the online etymology dictionary, this comes from the Greek geometries, the land measurer. The historian Herodotus said geometry came from Egypt. The Nile flooded every year. It erased the property lines of every farm. So the Egyptians invented a method for measuring land precisely enough to put the boundaries back. That method was geometry. Applied? Practical. The science of putting reality back where it belonged. Now look at the other word, sacred. That comes from the Latin verb sacrare. The online etymology dictionary defines it like this: to make holy, to consecrate. And underneath those meanings, the original sense, to set apart. Sacred does not mean religious. Sacred means set apart. Set apart from what? Set apart from things that are arbitrary. Set apart from things that could just as easily be different. A hexagon's interior angles add up to 720 degrees. That cannot be different. A square's diagonals cross at exactly 90 degrees. That cannot be different. These measurements are set apart from arbitrary measurement by mathematical necessity. So put the two words together. Sacred geometry means the set-apart measurements of the physical world, the measurements that are not arbitrary, the measurements that nature itself keeps using. Once you know what the two words actually mean, the next question is uncomfortable. Because most of what people are sold under the name sacred geometry. Is it actually true? Mario Livio is an astrophysicist. He spent 2 years measuring the most famous golden ratio examples in the world. And he concluded that most of them are not what you have been told they are. His book is called The Golden Ratio, The Story of Phi, published in 2002. It works through the popular claims one by one. The Parthenon, the most famous case. The claim is that the front of the Parthenon was designed around the golden ratio. Livio measured it. He checked the historical record. No contemporary Greek source ever mentions the golden ratio in connection with the Parthenon. The measurements only fit if you pick convenient reference points and ignore inconvenient ones. The mathematician George Markowsky published the same finding in the College Mathematics Journal in 1992. The case is dead. The Mona Lisa. Same problem. The overlays you have seen on social media work by selecting which features count. Pick different features, you get different ratios. None of them is the golden ratio specifically. It is cherry picking. The Great Pyramid, the Mondrian paintings, the golden rectangles in textbooks. Same pattern, numbers picked after the fact to fit a story that sold books. And then there is the nautilus shell, the image you have seen 1,000 times. Spiral in a shell. Overlay a golden spiral. They match. Except They do not match. The mathematician Christopher Bartlett published a study in the Nexus Network Journal in 2018. He measured 80 nautilus specimens at the Smithsonian Institution. Mean ratio, 1.31, not 1.618, not the golden ratio, not even close. This matters because it has to be said clearly. Most of the famous golden ratio examples are wrong. The Parthenon, the Mona Lisa, the nautilus shell, all of them. The astrophysicist Mario Livio went through them one by one, and the math does not hold up, which means we have to throw out the romantic version of sacred geometry. So here is the real question. If the famous examples are myths, what is actually verifiable? Picture a bathroom floor. The tiles have to fit together with no gaps. Only 3 regular shapes can do this: triangles, squares, hexagons. So here is the question almost no one asks. Why is only one of those 3 shapes ever found inside a beehive? A Roman scholar named Marcus Terentius Varro asked this question in the year 36 BCE, over 2,000 years ago. He noticed that bees were using hexagons. He suspected hexagons used the least wax to enclose the most honey, but he could not prove it. A Hungarian mathematician named Laszlo Fejés Toth proved part of it in 1943, but only a partial case. It took another 56 years. In June of 1999, a mathematician at the University of Michigan named Thomas Hales finished the full proof. He published it in a journal called Discrete and Computational Geometry in 2001. Peer-reviewed, mathematically complete. The honeycomb conjecture became a theorem. What the theorem says is this: if you partition a flat surface into equal area regions, the regular hexagonal pattern has the smallest total perimeter of all possible patterns, forever. No other shape can beat it. Bees do not pick hexagons. Bees minimize the wax they need to make. The geometry that minimizes wax for storing honey is mathematically forced to be hexagonal. The hexagon was always going to win. Now look at a snowflake. Why is it always 6-sided? The answer is the water molecule itself. 2 hydrogen atoms bonded to 1 oxygen atom at an angle of about 104.5 degrees. When water freezes in the upper atmosphere, those molecules pack together in a hexagonal lattice. 6-fold symmetry comes out the other side. Johannes Kepler wrote the first systematic study of this in his book On the 6-Cornered Snowflake, published in 1611. That short book is considered the founding text of crystallography. Now look at a sunflower. Count the spirals going clockwise in the seed head. Then count the spirals going counterclockwise. You will get 2 numbers, one after the other, in the Fibonacci sequence. The French physicists Stéphane Douady and Yves Coudert published a paper in the Journal of Theoretical Biology in 1996. They explained why each new seed grows at an angle of about 137.5 degrees from the previous one. That specific angle is the only angle that lets you pack the seeds with maximum density and 0 overlap. The Fibonacci spiral is not chosen by the plant. The Fibonacci spiral is forced by the math. So now you have 3 independent natural systems. The hexagonal honeycomb is mathematically forced. The 6-sided snowflake is mathematically forced. The Fibonacci spiral in a sunflower is mathematically forced. 3 independent natural systems, all converging on geometry that was already there before life arrived to use it. Which raises the next question. If a tiling problem has only one mathematical answer in 2 dimensions, what happens when you go to 3? Take a piece of pyrite, fool's gold, pick it up. The shape in your hand is a dodecahedron, 12 flat faces, the same geometry Plato assigned to the cosmos itself. And the pyrite has not read Plato. 2-dimensional tilings have one answer. 3-dimensional regular solids have exactly 5. Euclid proved this in the 13th book of his Elements, around 300 BCE. The 5 are these: tetrahedron, 4 triangular faces; cube, 6 square faces; octahedron, 8 triangular faces; dodecahedron, 12 pentagonal faces; icosahedron, 20 triangular faces. That is the entire list. There can never be a 6th. Euclid proves it geometrically. The math allows no other shape. Plato assigned these 5 shapes to the 5 elements 2 centuries earlier. In his book, the Timaeus, tetrahedron got fire, cube got earth, octahedron got air, icosahedron got water, dodecahedron got the cosmos itself. Plato did not have a microscope. He had no way to know that minerals would later be measured and found to have these exact shapes. But they were measured. And they did. Galena, lead sulfide, the mineral that gave the ancients their lead, crystallizes in perfect cubes. Halite, the crystal name for table salt. Cubes, sodium and chlorine ions packed in a perfect cubic lattice. Fluorite, crystallizes as octahedra, standard form in any mineralogy textbook. Diamond, octahedra. Pyrite, cubes and octahedra in a form called the pyritohedron, which is an irregular dodecahedron. The faces are pentagonal. The angles are not perfectly Platonic, but the geometry is. So here is the reveal. There are exactly 5 regular 3-dimensional solids: tetrahedron, cube, octahedron, dodecahedron, icosahedron. Euclid proved this in his Elements. There can never be a 6th. And modern mineralogy finds atoms assembling themselves into these exact 5 forms at the smallest scale we can measure. Plato named these shapes. He did not invent them. They were already there. Inside the minerals, inside the matter, inside the rules of how reality assembles itself. If atoms assemble themselves into these forms, what was the upper limit of what the ancients could observe? In April of 1982, a man named Dan Shechtman was on sabbatical from the Technion in Israel, working at the U.S. National Bureau of Standards outside Washington. He was looking through an electron microscope at an aluminum alloy, and he saw something his entire field had spent a century declaring impossible. But before we get to him, walk through the history, because if these geometric forms are real, then anyone who looked closely should have found them. And many people did, in completely different places, with no contact between them. India, the Vedic tradition, the Shulba Sutras, dated to around 800 BCE, geometric instructions for constructing fire altars. They contain a statement equivalent to the Pythagorean theorem, hundreds of years before Pythagoras. And the Sri Yantra, the central symbol of Hindu sacred geometry, is built from 9 interlocking triangles producing exactly 43 smaller triangles around a single central point. The construction requires solving multiple simultaneous geometric constraints. It is not decoration, it is mathematics. It is, and then there is the strongest case. The case where the convergence is fully documented and undeniable. Islamic architecture, Persian and Anatolian craftsmen. By the year 1200 CE, the system was already mature. They used a set of templates called Giri tiles, 5 shapes that fit together to make every pattern in the catalog. By the year 1453, the Darbai Imam shrine in the city of Isfahan was complete. The geometric pattern covering its walls is what mathematicians now call an aperiodic quasi-crystalline tiling. The pattern never exactly repeats, even though every section follows the same precise rules. 5-fold symmetry, forbidden in any classical periodic crystal. But there it is, across the entire wall of a 15th century shrine. What Mark Passio calls the principle of correspondence, the as above so below idea from the Hermetic tradition, is exactly this observation. the same mathematical structure recurring at every scale and across every tradition that bothered to look. In 1974, an Oxford mathematician named Roger Penrose published the first mathematical formalization of an aperiodic tiling with five-fold symmetry. He thought he had discovered something new. In 2007, two scientists, Peter Liu of Harvard University and Paul Steinhardt of Princeton University, published a paper in the journal Science. The paper proved that medieval Islamic craftsmen had achieved Penrose's discovery centuries earlier, centuries before Penrose. The same geometry. Discovered, not invented. And then Shechtman, April 8th of 1982. The aluminum manganese alloy he was studying showed a diffraction pattern with 10-fold symmetry. Classical crystallography said this was impossible. Five-fold symmetry cannot tile space periodically. The textbook said so. Linus Pauling, a two-time Nobel laureate, called Shechtman a quasi-scientist, mocked him publicly. His own research group asked him to leave. He was right. Quasi-crystals exist. The pattern he saw was the atomic scale signature of icosahedral symmetry, the same icosahedron Plato had assigned to water 2,300 years earlier. He won the Nobel Prize in Chemistry in 2011. Plato's geometry of water exists at the atomic scale. So here is what just converged. Vedic altar builders, Persian craftsmen, Greek philosophers, and modern crystallographers, separated by oceans and millennia, all independently arrived at the same geometric forms. And modern science has now proven that what they found is mathematically forced. The patterns were always going to be there. If craftsmen in Persia were doing 14th century mathematics that the West would not formalize until 1974. And if Plato's geometry of water exists at the atomic scale, then why is none of this in any school you ever attended? Pull up your old high school transcript. Find arithmetic. Find geometry. Now look for music theory. Now look for astronomy. They are not there. 3 of the 4 classical mathematical disciplines were quietly removed from the education you were given. And they did not call themselves classical mathematical disciplines. They had another name. The name was the Quadrivium, from the Latin words quatuor, meaning 4, and via, meaning way. The 4 ways, 4 disciplines that work together. Arithmetic, the pure study of number, geometry, the study of number in space. Music, the study of number in time through the ratios of sound. And astronomy, the study of number in space and time together through the motion of bodies in the sky. A Roman philosopher named Boethius coined the word quadrivium around the year 500 CE. The 4 disciplines had a companion, the trivium. 3 ways: grammar, logic, and rhetoric. Together, the trivium and the quadrivium formed the 7 liberal arts. That word liberal is the key. It comes from the Latin word liber, which means free. The 7 liberal arts were the disciplines a free person was expected to learn. The arts proper to freedom, as distinct from servile arts, which were the mechanical trades. A free citizen of medieval Christendom studied all 7, from late antiquity through the high Middle Ages. Then they started to disappear. The displacement began in the 14th century with the Italian humanist Petrarch. He proposed a new curriculum called the Studia Humanitatis, built around classical literature and rhetoric. By the 17th century, the Quadrivium was a specialty interest. By the 19th century, when modern compulsory schooling was being designed, the Quadrivium had no place in it. What you got was arithmetic, stripped of its quadrivium framing, geometry, detached from its name, its origin, and its purpose. Music as an elective, not as the study of harmonic ratio. astronomy as a unit inside 7th grade science, not as the geometry of the cosmos. Mark Passio has been documenting this on the Quadrivium podcast on what on earth is happening for over a decade. He is right. The Quadrivium is the missing half of an education in being free. So here is the reveal. The classical liberal arts had 7 disciplines. The trivium of grammar, logic, and rhetoric, and the quadrivium of arithmetic, geometry, music, and astronomy. The word liberal comes from the Latin liber, which means free. These were the arts proper to a free person. 3 of the 4 quadrivium disciplines were removed from the curriculum you were given. You inherited the arithmetic. They kept the rest. So what do you do with this? Starting today. Look at the table in front of you right now. There is almost certainly wood grain. Its rings are circles. There is almost certainly a salt shaker. Its crystals are cubes. There is almost certainly a screen. Its pixels are arranged in hexagonal subpixels. You are surrounded by the alphabet of this entire video. Right now. The job for the next 24 hours is to read the room. 4 patterns. Each one tells you what physical law is operating. Hexagons mean efficiency. Wherever space has to be divided up into equal areas with the smallest amount of boundary, you will find hexagons. Honeycombs. Basalt columns at the Giant's Causeway in Ireland. Graphene. Dragonfly wings. The lenses of an insect's compound eye. The hexagon is the signature of an efficiency problem being solved. Spirals mean growth. Wherever a structure grows by adding to itself in proportion, you will find a spiral. Most spirals are not golden ratio spirals. Most are simply logarithmic spirals. But the family is universal. Snail shells, hurricanes, galaxies, fern fronds, water draining from a sink. The spiral is the signature of self-similar growth. 5-fold symmetry means biology or a periodic order. It is forbidden in periodic crystals. It cannot tile space the normal way, but it shows up everywhere life is involved. Starfish, apple cores when you cut them in half. The cross-section of an okra pod. The flowers of hibiscus, periwinkle, and most flowering plants. 5 petals, 5 points, and as we have seen, in the quasi-crystals Shechtman discovered. 5-fold symmetry is the signature of life or of aperiodic order at the atomic scale. Faint gold geometric overlay lines trace each underlying Platonic structure. Clean technical illustration. No text, no letters, no words, no labels, no symbols, no numbers, no characters of any kind. Platonic solids mean mineral structure. Salt crystals are cubes. Fluorite forms octahedra. Pyrite forms dodecahedra. Garnet forms a different kind of dodecahedron. If you have a rock collection, you are holding examples of the Platonic solids. Here is the work. Find 3 of these in the next 24 hours. 1 plant, 1 building, 1 mineral or biological form. Name the pattern. That is the threshold. The moment you can read the structure of reality without needing anyone to interpret it for you, the trivium and the quadrivium have done what they were built to do. The Greeks had a word for this kind of direct seeing. Theoria, from the Greek root for sight. Not theory in the modern sense. Theoria in the original sense. The direct perception of structure. That perception is what they took from you when they took the quadrivium. The capacity to look at the world and see its grammar, not by faith, not by belief, by measurement. Sacred geometry is not mysticism. It is the set-apart measurements of the physical world. The measurements that nature uses because nothing else works. The hexagon does not care whether you believe in it. It is the answer to a problem reality has been solving since before you were born. Now you have the key. Read the room. Subscribe to Immutable Mechanics.